Question number 1.20 from NCERT. Mail, please take the pick
Webber
here.
sir,
Yes, Bharat.
I've sent you the doubt on WhatsApp.
Okay, sure. I'll include in this class. Here you
And
can
I'll
take the pick.
and I'll be sending more doubts.
बेटा थोड़ी ये मेहनत पहले कर लिया करो तो yes थोड़ा टाइम बच जाए but do it quickly. Yes, positive charge को repel करता है and they both will be having same magnitude because both the charges are same 2 microcoulomb and exactly opposite because the positive charge repel. The other charge of -5 microcoulomb, this will attract it, but जितना ये attract करेगा उतना ही force से the other
Sir,
side.
what do we have to find in this question?
Net force on the charge at center.
तो नेट फोर्स तो ऐसे जीरो ही रहेगा.
Zero ही होगा.
यस सर.
Charge at center, net 1 microcoulomb. It will be 0 because -5 F2 cancel out, F1 cancel out, so that net force will become 0. Tanishka, clear?
Yes, sir.
Okay. Next question here is, Suzanne understood this 36 one?
Yes, so even I got 0, but in the book, like the answer was different. So I thought maybe there's some different method or something.
No. I think there's a misprint then. The option.
Yeah, it was 1 point something. So I thought, how is it possible? That's why I sent it.
Yes. I know that the answer to the question should have been, this is the Akash package, no?
Yes, so the module.
Yes. It has to be like this. This you have to calculate actually. That ABCD marking is different. So suppose if you consider this question also, find the force on the charge kept at the center. The 1 microcoulomb charge is kept at the center. This side length is 10 centimeter, 0.1. अभी क्या होगा, ये positive charge इसको repel करेगा by the force F1. This positive charge is repelling 1 microcoulomb, which is K Q1 Q2 by R square. So K Q1 into Q2 by R square. इसको हम F ले लेते हैं थोड़ी देर के लिए. The 5 microcoulomb is attracting towards itself by the another force which is F2. F2 will be K into 5 into 1 divided by R square. Similarly, the other 2, this is repelling 2 plus 2. 2 minus 5 is attracting. So both the side F1 plus F2, that is the total force. F1 plus F2 is 7. K is 9 into 10 to the power 9 if you have to calculate that. And R is 1 by root 2. R is the half of the length of the diagonal. अगर किसी स्क्वायर की साइड लेंथ a है, then half of the length of diagonal is a by root 2. So that will become 0.1 by root 2 divided by 0.1 by root 2 whole square. 7 into 9 into 2 into 10 to the power how much? 9, and this is minus 2, 11. Right?
Yes, sir.
Yes, sir.
Sir, I have a question.
एक second बेटा. 126 into 10 to the power 11 Newton. अभी ये इतना इधर भी है, इतना इधर भी है, और दोनों के बीच में 90 degree. So if we force on one of the diagonal as F, these two forces F and F at an angle of 90 degree. इनके resultant का formula कुछ होता था root a square plus b square plus 2ab cos theta. Since theta here is 90 degree, cos 90 will become 0. So it will be F times root 2. 126 into 10 to the power 11 multiply by root. Right?
Yes.
Is this the answer?
Yes,
I
sir.
mean, similar 1 point something you said.
Yes, sir.
1.78 into 10 to the power 13 Newton. I think that's the answer. No. We missed that micro. So that will be into 10 to the power minus 12 as well. दोनों charges के micro coulombs. So it will be into 10 to the power minus 12, which becomes 17.8 Newton. I think so. Check the calculation. So that would be the actual question as per the answer. But हमें
Yes,
answer
so
के
because
हिसाब से
all
question.
the 4 questions which I've sent you, all of them have different answers. That's why I've sent you.
Maybe you are checking from some other exercise, or maybe it's printed in some other
No,
exercise.
so I checked it twice only, then I sent it to you.
Okay. 37, a charged wire AB of length L is placed inside a sphere as shown in the figure. Linear charge density of wire lambda is kx. X is the distance measured along the wire from end A and K is constant. Calculate the flux through the sphere. Flux के लिए formula था flux is charge enclosed by epsilon naught. Total charge inside. Total charge inside we have to calculate with the help of integration. क्योंकि यहाँ पर charge density is non-uniform. For non-uniform charge density, we need to do the integration. Integration इसलिए करना है क्योंकि हमें total charge चाहिए. Then total charge upon epsilon naught, that will be the answer. Total charge on this wire divided by epsilon naught, that's according to Gauss theorem. The total flux coming out of any closed surface is charge enclosed by epsilon naught. On this wire, on this rod, we need to calculate the total charge. This is L. यहाँ से x डिस्टेंस पे dx थिकनेस पे सपोज चार्ज ले लेते हैं dq. ओके सो तनिष्का एंड उर्वशी लैम्डा क्या होता है? लैम्डा इज जो यहाँ पे लीनियर चार्ज डेंसिटी गिवन है. व्हाट डज दिस मीन? दिस मीन्स चार्ज पर यूनिट लेंथ. यूनिट लेंथ के चार्ज को हम बोलते हैं ये लीनियर चार्ज डेंसिटी. बट हियर दैट डेंसिटी इज नॉट कांस्टेंट. वो डेंसिटी x के साथ चेंज होती जा रही है. इट इज इंक्रीजिंग विद x. x equals to 0 पे it is 0, and as we go further the density is increasing. So हम पूरे पे एक साथ calculate नहीं कर सकते. We have to consider a small length dx. dq will be lambda times dx, and then we integrate. Integration of dq is lambda times dx. dq क्या है? चार्ज है dx लेंथ पे. dx ये छोटी सी लेंथ, dq उस पे चार्ज. यूनिट लेंथ का चार्ज लैम्डा, सो dx लेंथ का चार्ज लैम्डा इंटू dx विच इज dq. ऐसे हमें टोटल चार्ज कैलकुलेट करने के लिए x पे इंटीग्रेट करना है. x is changing from 0 to L. Lambda is kx times dx. Here it will be q. Q comes out k times L square by 2. Is it not matching? K L square by 2 epsilon naught should be the answer.
That's what I got to do.
No, so it's given 2k L square upon 4 epsilon naught.
It's given
2k L square upon 4 epsilon naught.
I think the simplify with the same object.
2k L square upon 4 pi epsilon naught. This one.
No, sir, opposite ways. 4 upside, 2 downside. Flux is q enclosed by epsilon naught. Might be if you rearrange that pi and epsilon naught, it may become that capital K, the Coulomb's constant. It is given in terms of capital K. Yes, sir.
So if you multiply this by
2 pi in the numerator and denominator. One upon 4 pi epsilon naught is capital K. So capital K into 2 pi K times L square. Is that the answer?
Yes, sir.
So here capital K is the Coulomb's constant. Small k is that constant which was given here in terms of lambda. Lambda is k into x.
Oh, okay. I just found out for the small k, then I thought maybe I am not getting it.
Method of calculation flux, that total charge inside divided by epsilon naught, that will be the flux, so total charge inside. अगर ये यूनिफॉर्म चार्ज डेंसिटी होती तो हम डायरेक्टली कैलकुलेट कर लेते लैम्डा इनटू द टोटल लेंथ if this would have been uniform. Since it is not uniform, the lambda is changing with the position. So we'll consider a very small length dx, calculate the charge on that small length by using the unitary method, and then we'll integrate this. Right?
Yes.
Okay, next question. Two plate sheets of charge density plus sigma minus sigma are kept in air. What are the electric field intensities at point A and point B? Similar questions we did in the DPPs. Maybe answer is wrong in this case also. Plus sigma for the upper one minus sigma here. Point A and point B. We have to find the electric field due to this. These are the sheets. Electric field due to a sheet, infinite sheet, is given as sigma by 2 epsilon naught. For positive charge, it is away. For the negative charge, towards. Electric field due to infinite sheet is equal to sigma by 2 epsilon naught. For positive charge, it is away. For positive charge, it is away. For positive charge, it is away. Negative charge की suppose E2 है. Magnitude wise it is same, only the direction wise it is. Negative charge अपनी तरफ attract करता है, so towards itself E2, towards itself and towards itself. In between the two plates, E1 and E2 electric fields are in same direction. Sigma by 2 epsilon naught plus sigma by 2 epsilon naught, that becomes sigma by epsilon naught. बाहर की तरफ A का 0 और C का भी 0. अगर हम यहाँ पे C ले लेते हैं, because these two fields are opposite, same in magnitude but opposite in direction, so they will cancel out. Right?
Yes, sir.
Yes, sir.
So at point A it will be 0, at point B it is sigma by epsilon naught, क्योंकि दोनों sheets की electric field को हम add कर लेंगे, sigma by 2 epsilon naught plus sigma by 2 epsilon naught, it will become sigma by epsilon naught. Question number 39. A charged particle of charge q, mass m, moving with velocity ui, enters a uniform electric field. E is equal to E times J cap. So electric field y direction में charge particle enter करता है x direction में, हमें उसकी velocity और उसका displacement बताना है t time के बाद. Electric field is in y direction. It is E is equal to E times J cap. E is equal to E times J cap, and the particle enters with U times I cap. Mass is m. Since electric field is in y direction, इसके ऊपर जो force लगेगा किसी भी charge पे, positive charge पे force लगता है electric field की direction में, negative charge पे force लगता है opposite direction of electric field. This is x, this is y.
force on the electron, force on the charged particle is in y direction. So force y direction में, इसलिए इसका acceleration भी y direction में होगा. Acceleration in y direction is equal to F upon m, which is QE upon m in y direction. इस पार्टिकल पे केवल y डायरेक्शन में फोर्स लग रहा है, इसलिए इसकी y डायरेक्शन में वेलोसिटी बढ़ती जाएगी, जो कि इनिशियली जीरो थी. Initially, particle does not have any velocity in y direction. As it goes further, y direction में इसकी velocity बढ़ती जाएगी. X direction velocity will remain unchanged, जैसे कि पैराबोला में होता था in the projectile motion. X direction में कोई force नहीं है, X direction की velocity same as u all the time, but y direction velocity will be changing. Vy.
Excuse me, sir.
Yes, Manav.
सर आप 37th क्वेश्चन फिर से बता सकते हैं, समझा सकते हैं?
ये ऊपर वाला
नहीं सर, 37th वाला, वो सर्कल वाला.
37 circle वाला. Okay. 37 question was that एक हमने wire लिया है and that is kept inside a sphere. This wire is charged, but it is having non-uniform charge distribution. The charge density is not constant; it is changing with x. इस wire के ऊपर अगर हम कुछ charge को show करते हैं, then initially it does not have any charge. It increases, but जैसे जैसे हम आगे जाते हैं वैसे वैसे इसकी density बढ़ती जाती है. This is a kind of charge distribution on it. अब किसी भी type का charge हो, according to Gauss theorem, the total electric flux coming out of any closed surface is always Q by epsilon naught. The total flux coming out of any closed crossing surface is Q by epsilon naught. Right?
Yes sir.
So ये Q by epsilon naught में Q निकालना है हमें. Q निकालने के लिए अगर ये यूनिफॉर्म डेंसिटी होती, लीनियर चार्ज डेंसिटी इज चार्ज ऑन अ यूनिट लेंथ ऑफ वायर. Length L है. If it would have been constant, then we could directly multiply Q is equal to lambda times L. But since the density is not constant, density is changing with x, we cannot do the integration. We have to do the we cannot do by direct multiplication. We have to do the integration. When a quantity is continuously changing, for a small change, we calculate its value. Small length dx. For this small length dx, we calculate its value by using the similar type of formula. Charge is charge density into length. So dq is charge density lambda into length, and length is dx. Manav, this is clear?
Yes sir.
Charge density मतलब charge on a unit length. अभी length ली हमने dx, so charge dq will be lambda times dx. Since lambda is a function of x, तो lambda को put कर लेंगे kx. Lambda is k into x. This charge becomes kx times dx. Charge on this very small element, पूरे वायर में से एक छोटा सा dx का एलिमेंट लेंगे तो उस पे चार्ज है kx into dx. To calculate the total charge कैलकुलेट करने के लिए ऐसे जितने भी छोटे छोटे dx होंगे उन सब पे कैलकुलेट करके we have to integrate. इंटीग्रेशन का मतलब समेशन, और समेशन करने के लिए we do integration on both the side, starting from 0 to final length. Substitute the value of k. Lambda is k times x. Correct?
Yes sir.
एक को बाहर निकाल लेते हैं. x का इंटीग्रेशन क्या होता है?
X square by 2.
X square by 2, and then apply the limit. So it become k L square by 2. We got the total charge on this rod as KL square by 2. इस चार्ज से हमें चार्ज मिल गया अंदर. Apply the Gauss theorem. According to the Gauss theorem, the total flux that comes out of any closed surface is Q by epsilon naught. Q is KL square by 2, so it becomes KL square by 2 epsilon naught. अब बुक में जो आंसर दिया था वो कैपिटल के टर्म्स में था. कैपिटल के मींस कूलॉम्स कांस्टेंट. कैपिटल के होता है 1/4 पाई एप्सिलॉन नॉट. इस 2 एप्सिलॉन नॉट में ऊपर नीचे 2 पाई मल्टीप्लाई कर दिया. 1/4 पाई एप्सिलॉन नॉट is capital K, and then it will become 2 pi KL square.
Understood,
This
sir.
is that is small k. That is the answer given. Answer, this is also correct, but the form of answer was given in terms of Coulomb's constant, capital K in terms of capital K. Got it?
Understood, sir. Yes, sir.
Okay. Yeah, this question says the electric field exists in y direction, a charged particle enters in x direction, and we have to find that this will be, now it is moving in x as well as y direction. In x direction there is no acceleration क्योंकि कोई force x direction में नहीं है, so velocity in x direction remains constant, just like in the projectile motion we did. Velocity in x direction will remain constant.
So इस क्वेश्चन में फाइनली क्या निकालना है?
Displacement, equation of the path. We have to find the magnitude of the displacement of particle after time t. Magnitude of velocity and magnitude of displacement. X direction acceleration is 0, y direction acceleration is constant. So in this whole path, x direction displacement is covered with constant velocity, y direction displacement is covered with constant acceleration with the initial 0 velocity. Right?
Yes.
This till this step clear?
Yes, sir.
Suzanne?
Yes, sir, it's clear.
Okay, so now when this particle comes out here, it has two velocities. Initially it has only u, there was no y component. X direction final velocity is u. Y direction final velocity will be given in terms of, so we have to calculate in time t. T is equal to 0 in time t. Y direction velocity v is equal to u plus a times t, and a is qe by m into t. So when we calculate the magnitude of total velocity here, magnitude of total velocity v will be root vx square plus vy square. Vx तो हो गया u and vy is qe by m times t square. This is the velocity, magnitude of velocity after time t. Correct? Magnitude of velocity after time t. इसकी y डायरेक्शन में डिस्प्लेसमेंट के लिए क्या करेंगे? मैग्नीट्यूड ऑफ डिस्प्लेसमेंट, x डायरेक्शन में डिस्प्लेसमेंट हो रहा है विद कांस्टेंट स्पीड, कांस्टेंट वेलोसिटी, सो x इक्वल्स टू ut. y डायरेक्शन में it is going with a constant acceleration, so half at square. A is qe by m into t square. Displacement will be this s. The displacement in s direction will be root of x square plus y square.
it will be ut square plus half QE by m times t square whole square. Correct? This is the answer.
Could you re-explain the y equals to half AYT square part again?
Second equation of motion, s is equal to ut plus half at square. Since it is the constant acceleration, initial velocity in y is 0.
Oh, okay, sir. Got it.
Acceleration is QE by m. This t also we can calculate from the equation of x. T is equal to x upon u. So y के formula में हम इसको put करते हैं, then we also get the equation of path. Y is equal to half QE by m into t. T is x by v, x by u whole square. This is the equation of path QE upon 2mu square times x square. Equation of path of this particle, which is moving along x direction, but there is an electric field along y direction. Right?
Yes.
Yes, sir.
Okay. Next doubt. I'm sending more doubts in the group. कुछ लोगों ने भेजे हैं अभी. Okay. Bharat has asked some theoretical questions. Okay. Right. So I am sharing on my screen. Saksham, कोई doubt नहीं है आपको? Kriti, your doubts? You haven't asked yet. Kriti,
नो सर
अभी तो आप कह रहे थे कुछ doubts है मेरे.
सर वो मैंने हो गए थे सर इतने वो डिफिकल्ट नहीं है एक दो बार ट्राई करूंगी आ जाएंगे
करूंगी आ जाएंगे. Okay. Ishka, can you send your doubt? Bharat? Yeah, this is your doubt. The question
Yes,
is when what is
yes,
round
yes. These are the doubts that I had given.
Anybody like to explain this? Question is when a glass rod is rubbed with a silk cloth, charges appear on both. A similar phenomenon is observed with many other pair of bodies. Explain how this observation is consistent with the law of conservation of charge. Arnav, would you like to explain this?
Sure, sir. I don't know which one gets positive or negative, but when we rub an object with another, one of them gets a positive charge and the other one gets a negative charge. And if we add the charges on both of them, we'll get zero. So hence it's consistent with conservation of charge.
Right. Bharat, understood?
Yes. Can you please
Irrespective of
repeat?
the bodies involved, irrespective of the nature of bodies involved, one body if acquire positive charge, the other body must acquire exactly same amount of negative charge. That means total charge is still zero in this whole system of both the bodies rubbed together. It is not violating the conservation of charge. The total charge is still same. The only difference maybe when you change these pair of bodies is the amount of charge or the quantity of charge that is being produced. Right? Got it?
Yes.
Okay. Second, electrostatic field line is a continuous curve. This is a field that a field line cannot have certain breaks. Why not? Mr. Bharat, electric field lines terminate where? Where does the electric field line terminate?
Negative charge.
Negative charge. So unless there's a negative charge present, it cannot disappear, it cannot break. It has to be a continuous smooth curve.
right?
While I write it my answer, so I have to write that electrostatic field line can only terminate at a negative charge.
Yes, it is always continuous curve. It cannot terminate or it cannot disappear on its own unless there is a negative charge present in that system. So in vacuum or without any negative charge, it is not possible for electric field line to disappear or to have any break. Got it? Correct. Okay. Anushka, your doubt?
सर मेरा डाउट सॉल्व हो गया था सर, वो न्यूमेरिकल में प्रॉब्लम थी कुछ.
न्यूमेरिकल में प्रॉब्लम थी, डाउट सॉल्व हो गया. दैट्स वेरी गुड, वंडरफुल. अनुराग, नो डाउट. वेरी नाइस. वंडरफुल. ठीक है, फिर हम आगे कुछ कुछ क्वेश्चंस कर लेते हैं फ्रॉम दी सक्षम. कनन, आपके कुछ डाउट थे शायद. कनन, 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 not in the meeting. Okay. रुद्रांश, नीति,
यस सर.
बेटा कोई डाउट नहीं? एनसीईआरटी, एसएल, कुछ भी? नो,
सर अभी तो नहीं है सर.
पढ़ाई नहीं हो रही मतलब? ओके, चलो मैं क्वेश्चन सेंड कर रहा हूँ ग्रुप में. These were asked by Kanan. I think some of them have been taken already. Just for ये क्वेश्चन वैसे हम लास्ट क्लास में शायद कर चुके हैं. The NCERT ones. हाँ, ये हम कर चुके हैं वैसे लास्ट क्लास में, बट जस्ट फॉर दी ओके, वी हैव ऑलरेडी डन दिस इन द लास्ट क्लास. और किसी को कुछ डाउट हो तो पूछ लो, अदरवाइज वी कैन स्टार्ट विद द नेक्स्ट. अब मैंने आप लोगों को, शायद अभी सबको नहीं गए होंगे, कुछ लोगों को
Sir,
आपकी यूजर आईडी और पासवर्ड सेंड किए हैं. यस यस भरत, बोलो.
I had sent you another doubt.
I haven't received yet.
It was the second part.
Okay, second part I didn't find it worth mentioning because it is in the notes itself. That means you are not revising the notes. Electric field lines can never cross each other at any point. Yes,
You
Mr.
have
Rahul.
directions, and they will be going towards two different negative charges, so it's not possible.
Right, at that point, there will be two different directions of electric field. Correct? Electric field की direction होती है always along the tangent. Tangent to the electric field line give the direction of electric field at that point. If two electric field line cross or intersect, that means at one single point there are two different direction of electric field lines, which is not possible. Right? Mr. Bharat, revise your notes carefully. ठीक है, और किसी को कोई डाउट नहीं है तो फिर मैं, हाँ शायद मिहिर ने क्वेश्चन पूछा था एनसीईआरटी से।
सर जो प्रेप डोर पे टेस्ट हुआ था उसका रिजल्ट कब आएगा?
The result, I think I have increased the time limit to till Sunday. So after that only, अब वो भी मुझे अभी कुछ लोगों को दिखाना है, those people who don't know what exactly prep door is. So in the last 10-15 minutes, many of you don't know this word prep door. What does that mean? Okay. Mr. Mihir, can you read the question? I don't have NCRT here as right
So
now.
a lot of questions in the test. So physics वाला part तो आता था, but वो maths नहीं हो रही थी उसकी.
Yes, maths is an integral part of physics.
Yes, sir, but so how do we work on that? Because that kind of maths we haven't learned or we're yet to learn. Like in one of the questions, we needed the sum of a harmonic progression.
No, not the harmonic progression. It was
in one
It is a
question.
logarithmic series. Yes. Harmonic progression summation. There is no formula. That's a logarithmic series. I will tell you. Yeah, your question is genuine, but yes, I think Meher, you asked 1.20.
Yes, sir.
1.20 is here already in this text. A point charge causes electric flux of -1 into 10 to the power 3 to pass through a spherical Gaussian surface of 10 centimeters centered at the charge. Okay. If the radius of Gaussian surface is doubled, how much flux will be passing through it? Right. So what was the what was the Gauss law? In any closed Gaussian surface, the total flux coming out of any closed Gaussian surface is 1 by epsilon naught times charge enclosed. किसी भी closed surface है, इसमें shape के लिए there is no mention. It does not matter कि वो shape कैसा है, whether it is a cube, whether it is a cuboid, a sphere, hollow sphere, cylinder, cone, any random irregular shape. If the charge present inside is q, which is same for all of them,
So same concept will be applied for all since they're
total
closed
flux
surfaces.
that comes out will be q by epsilon naught. किसी भी closed surface के अंदर अगर charge q रखा है, flux that comes out will be same because it is producing the same number of electric field line. Electric field line कितनी produce हो रही है वो charge पर depend करता है. Irrespective of the shape of that geometry or the size of that geometry, as long as the charge inside is same, the total flux will be same. Now it says अगर किसी 10 centimeter radius के sphere के अंदर Gauss flux is something, so if you double it, so even if you double it, it doesn't matter, it will have the exactly same. Since the charge inside is q, पहले वाले से जो flux calculate करोगे, which is q by epsilon naught, it has nothing to do with the size of this sphere. The flux coming out through the second sphere will also be q by epsilon naught. It's exactly same, and that value is given. So यहाँ से हम charge calculate कर लेंगे. Q by epsilon naught is flux. Q is equal to 5 times epsilon naught. Okay.
Got it.
Right. Yes. Any more doubt? Any concept doubt? Any conceptual doubt? No doubt. Okay. ठीक है, कोई बात नहीं. I am just logging into from my laptop, joining so that I can show you the. Yes, I can show you the prep door and the test that has been uploaded. So all of you can appear and can use that. तब तक अगर और किसी को कुछ डाउट है तो send it to me. Okay. DPPs के डाउट्स हो वो भी देख सकते हो आप लोग. DPPs are the one that I have shared.
ना किसी कॉन्सेप्ट में डाउट? हमने लास्ट पढ़ा था कैपेसिटर के कुछ कॉम्बिनेशन वाले क्वेश्चंस, combination of capacitors thermometer type series parallel, and I had shared so many DPPs related to that. Now, those are little more challenging than the NCRT and SL. Start with SL, so at least complete SL, and that should be completed within time frame before the next Friday. All the topics that we have done in class, at least the SL portion has to be completed. Very nice.
Vaibhav, sir.
Yes, Bharat.
Sir, do you mind if I join AP sir's class?
Everyone is welcome to join AP Sir's class. That's why it is there. You are supposed to join for revision if you are available at that time. And those who are not available can see the recording because those
He
classes
has
will be.
started current electricity.
हाँ बेटा, so that's why I'm saying now you have to. This is must because the portion that sir has started, I will be assuming that at least the basic definition and the basic part you know, so that we can utilize the time better. That's was the whole purpose. So sir is taking care of NCRT and the basic part of this NCRT and SL level. Numerical he will be doing from NCRT. He will also assisting you in solving the numerical from NCRT. My focus will be towards expansion of your knowledge so that we can apply those skills for the competitive level numerical also. That's why it is must for you. If you are not available at that time, check the recording. It is quite light in terms of the interaction, so you will be able to understand. रुद्रांश आपने क्लास की है अभी सर की अभी तक?
सर मैं तो बस ऐसे ही देख रहा था, अपलोड हुए थे लेक्चर, फिर अचानक से मैसेज आया था कि जॉइन दिस क्लास।
क्या क्या देख रहे थे ऐसे ही?
सर मैं तो ऐसे ही देख रहा था क्या क्या लेक्चर अवेलेबल है सर, फिर देखे कि उनके भी
अच्छा,
थे।
नहीं बेटा सर हर साल हमारे बच्चों को, ये अपने 11th वाले बच्चे जो हैं वो जानते हैं, उनसे फेमिलियर है,